Now let's talk a little bit about the materials, conductors and insulators. So an electrical conductor is a material in which charges can move freely. Electrical insulator is a material in which the charges cannot move freely. Insulators and conductors can be either charged by contact or they can be charged by induction. Induction is a process of charging a conductor by bringing it near another charged object and grounding the conductor. So charging insulators by rubbing. Insulating objects rub against each other result in the separation of charge. Objects start with 0 charge each, and each object gains equal but opposite charge. For example, silk rubbed on a glass rod. Once an insulator is charged, the charge remains where it is. Note, a piece of metal conductor may be rubbed all day but will not get charged. It is easy for charge in a metal to move around and avoid being transferred. So charging a conductor by contact. After rubbing a glass or silk rod with a silk cloth, the silk rod is left with a positive charge and the silk is left with a negative charge. Touching the glass rod to a metal sphere, the positive charge attracts some of the free electrons from the metal onto the glass. The glass rod is then removed. The metal sphere now has fewer electrons than protons, so it has a net positive charge. Even though negative charge is actually transferred, it is often said that the positive charge is transferred to the metal since the net effect is exactly the same. Grounding a conductor. This is how a conductor is discharged. Earth is a conductor because of the presence of ions and moisture. Also, it is so large with respect to anything else on its surface that it can be thought of as an infinite reservoir of charge. A charged conductor that is grounded, touched directly or indirectly, discharges because the charge spreads out by moving off the conductor and onto the earth. A modern electrical outlet accommodates a 3-pronged plug. Each hole serves a specific purpose. The round hole is for the ground pin on the plug, this one at the bottom that goes into the grounding wire. The small slot takes the small blade on the plug and connects it to the hot wire in the outlet that can actually cause a shock. The large slot takes the large blade and connects it to the neutral wire in the outlet. So what about charging a conductor by induction? So a glass rod, again, rubbed but with silk, the positively charged will leave the glass rod positively charged. It is held near a metal sphere, but it's not made to come into contact with it. The sphere is polarized as free electrons within the sphere are attracted towards the glass rod. When the sphere is grounded, the electrons from the ground move into the sphere, attracted there by the positive charges on the sphere. The ground connection is broken without moving the glass rod. Now the glass rod is removed with the ground wire still disconnected. The charge spreads over the metal surface as the like charges repel each other. The sphere is left by a net negative charge because of the excess electron. So one application is photocopier and laser printers. The operation of a photocopier is based off on the attraction of the negatively charged toner papers to the region on the drums that are positively charged. Now let's do an example. An electroscope. The electroscope is charged negatively and the gold foils hang apart. What happens to the leaves as the following operations are carried out in the order listed? Explain what you see after each step. So this is what an electroscope initially looks like. There is a conducting bulb and pole at the top, there are gold foil leaves hanging, and then there is an insulating base. So first of all, you will touch the metal bulb at the top of the electroscope with your hand. What will happen? Well, remember that static electricity that we did? Once you touch it, all the charge will go towards your hand, and the gold foil, all of it will become electrically neutral, and the gold foils will just hang limply down. Okay? Next, you bring the glass rod that has been rubbed with silk near the bulb, but you don't touch it. What will happen? So the glass rod will be positively charged, and when you don't touch it, what will it do? It will get all the negative charge on the top, and it will get positive charge, and the gold foils will again hang separately because they will each get a positive charge, and like charges will repel each other. Now again, what will happen when the glass touches the metal? Once the glass rod touches the metal, the positive charge will move to the bulb. Electroscope will have a net positive charge, and the glass rod will still be positive, pushes more positive charge onto the foil leaves, and they will hang even further apart. Now my next question is, what happens if you remove the glass rod and do absolutely nothing? What will happen? Well, yes, nothing will happen, right? Because it's in a vacuum and things are not moving around, it will stay that way for a really long time.